It is the 2019 past paper sum. Okay, 2019 paper question. This question, of course, available. I put your second tutorial few days before to the group. I think you noticed that then you have that copy. Okay. Right. In that tutorial, question number 13 is the 2019 question. Question number 13. Right? Question number 13. Right. Now that question you can now take. People taking that question, please read the part A in it. Okay, differentiation part. The differentiation part is regarding a curve sketching part. Okay. Well, now this is 2019 question. It's a very simple question. Okay. First, we'll try up to what extent everybody can do this question now. We are almost the end of the lesson. Another small part we have discussed to finish this lesson. There is a continuity part. The continuity part I supposed to discuss next day. Next day in the sense tomorrow we discuss that for the Monday group, and sometimes the same recording I can provide you. Then you can watch that recording, and I supposed to discuss this lesson now. Then 2 days you can cover up quickly. We can cover up the lessons, right? Okay. Now, people, question number 13, part A, 2019 question is this 2019 question, right? Right. Take that question paper first, and I'll give you like 5 minutes. First, try the first question. First part A. Part A. Try part A. There you are given fx. Part A, you are given fx. Fx given as 9 times x squared minus 4x minus 1 divided by x minus 3 to the power 3. For x not equal to 3. For x not equal to 3. Right. Show that f dash x, the derivative of fx is given by this. You have to differentiate this. Right. Differentiate this and take the first answer. Differentiate this and take the first answer. Right. I'll give like 2-3 minutes. Right. Now we have to take this as u. This as v. F dash x coming. We have to apply u upon v here, x minus 3, and this one we have to square, then we get power 6. Then x minus 3, the same thing we have to keep here, and now we have to differentiate this. 9 here, 2x minus 4 minus 9 times this we have to keep as the same, right? And this one we have to differentiate 3 times x minus 3 squared. X minus 3 to the power 2 is common. You can cancel down that. With here, we get 4. Then f dash x we get here 9, and here 9 we have. We can take that 9 out. Also take 9 out. Here we have x minus 3 to x minus 4, and here minus 3 times x squared minus 4x minus 1 divided by x minus 3 to the power 4, like this. Now simplify here. we get 2x squared here. And here we get minus 3x squared. Then we get minus x squared. Minus x squared. And here we get minus 6x. And here minus 4x. Here we get minus 10x. Here we get plus 12x. Then we get plus 2x. Correct, no? Minus 4x, minus 6x, minus 10x, and plus 12x, plus 10x. Then here we get 12, and here 3, 15. X minus 3 to the power 4. Right? We get like this. We can take a minus sign out from the numerator. So take minus sign out, and then you can factorize rest. Now factorize this. What are the factors, people, there? X minus 5, x plus 3, no? Right. And people, now here, applying this u upon v form and getting up to this 20 marks given. Right? And for the last answer, with for x not equal to 3, that must be written here. This is true, people. When x equals 3, what happens? 3 minus 3, denominator 0. Then the expression has no meaning, no? Denominator 0 means the fraction goes to people infinity. Infinity means meaningless answer, right? So therefore, we have write this x not equal to 3, right? X not equal to 3. So therefore, with this for x not equal to 3 given another 5 marks. Given another 5 marks. Okay, 25 marks given for the first part. Okay, right now. Right, next part. Sketch the graph of y equals fx, indicating the asymptotes, y-intercept, and the turning points. It is given that f double dash x is given. Find the x coordinates of the points of inflection of the graph y equals fx. Points of inflection. Okay. Right, now you know the method. F dash x is okay now. Now there you have to find horizontal asymptotes and vertical asymptotes and the points of stationary points, right? Okay. Right. First one we'll find vertical asymptotes. For vertical asymptotes, you know this denominator should be 0, x equals 3. Right. For this 5 marks given, right? To find the horizontal asymptote, people, you have to take limit x going to plus or minus infinity on the right hand side of this. At horizontal asymptote, you can write, people, fx limit x going to plus or minus infinity, the right hand side. So we will take here x out, x squared out, we get 9x squared. Once we take x squared out here, 1 minus 4 upon x minus 1 upon x squared. Here take this x out, then this will be x cube, no? When it is coming from this power 3, that will be x cube. Here then we get 1 minus 3 upon x to the power 3. This 10, this we can cancel down. When I put x infinity for every x, divided by, here when you put, you get, people, plus or minus infinity here, and here 1 minus 3 upon x. Right. Space not enough. Right. Now, people, this is 0. This is also 0. This is 0. Then within bracket we get 1. Numerator 9 divided by plus or minus infinity. You know this is, people, 0. Fx 0. For this 5 marks coming. Horizontal asymptote is y equals 0. Therefore, horizontal asymptote y equals 0 because fx is y. Right. Next one, we have to find, people, stationary points. You know, for stationary points, f dash x 0, f dash x 0, Then this is the dash x, no? Minus 9 x plus 3 x minus 5 x minus 3 to the power 4 should be 0. Then this implies the numerator must be 0, no? Then x equals minus 3 x equals 5. They are the x values. Right. So then finding these people, you get 5 marks. Five marks for this. Right? 5 marks for this. Five marks. Huh? And we have to find people the y coordinates at each of these x value. Right. For that also, marks given, each 5. X equals minus 3. Substitute that fx right hand side, minus 3 squared, 4 into minus 3, minus 1, minus 3 cube. People here, we get y coordinate when x equals minus 3, y coordinate coming as minus 5 by 6. Then one station point is minus 3, minus 5 by 6. Find in this point, y coordinate, you get 5 marks, people. For this 5 marks. And x equals 5, we get y. X equals 5, we get y. Substitute in that 5 where in that x, 9, 5 squared minus 4 into 5, minus 1 divided by 5 minus 3 to the power 4. Here we get, when x equals 5, y coordinate is coming 9 by 2. So therefore, for the next station point, 5, 9 by 2, another 5 marks given. Right. This is how we get the marks. Station points. These are the station points. But now in this case, we are not asked to, finally find the x coordinates of the points of inflection of the graph y equals fx. Then graph is to be sketched indicating asymptotes, y-intercept and turning points. Y-intercept mean, people, the point where the graph cuts the y-axis. To find that, we have to put, people, x equals 0 in the equation of the graph. Okay. Now we'll see. We need the next one, the table showing the sign of dy by dx. That means f dash x. Okay, now the table, the exercise we have to put -3 and +3 and +5. Right. +3 we have work lesson taught. -3 and +5 we have stationary points. This is a table. dy by dx or f dash x. X less than -3, -3x 3, 3x 5, more than 5. In each interval, you have to find the sign. Less than -3, put the minus infinity, no? Put that here. This is always positive denominator. Minus, minus, minus. This is minus. In this interval, put x equals 0 plus x4 also plus. Next one, more than 5 minus. Right. Finding the sign in each interval, people, 5 marks given for each. 5 marks here, 5 marks here, 5 marks here, 5 marks here. 20 marks coming, people, for this, right? 20 marks coming for this table. 20 marks. So therefore, don't ignore this preparation of the table, right? 20 marks. And here, gradient negative at -3, 0, positive. Therefore, this is a minimum. Minima. Local minima. And here, positive, 0, negative. Local maximum. Right. I will sketch the graph. Right. X equals 3, there is a word lesson taught. Right. X equals 5, y equal 9 by 2. Somewhere here. 4.5. There is a maximum. X equals -3. -3 is people somewhere here, no? Suppose somewhere here. X equals -3, y is -5 by 6. -5 by 6 somewhere here. Right. This is origin. We need to find their people the point where the graph cuts the y-axis. That is the meaning of y-intercept. Y-intercept. Okay. Y-intercept, we can find people, put in x equals 0. Put in x equals 0. We are here. Y come in as 9. This is 0. This is 0 minus 1. Here minus 3 to power 3. Y is people 1/3 coming. Right. Here this is a minimum graph. One-third. Here vertical asymptotes. Graph is like this. This is 1/3. Right. Now, there is a horizontal asymptote at y0. This way. Right. Maximize phi 9/2. 9/2 is here. This is 9/2, right? Okay. Write in only the coordinates enough. Phi 9/2 here. Then there is a maxima. This way coming, the graph. And for this graph correctly drawn 5 marks. For this graph correctly drawn 5 marks. And here showing the y-intercept people 5 marks. Marks given like that. Right. Thereafter, second derivative given. Find the x-coordinate of the points of inflection of the graph y cos fx. You know, points of inflection, people, we determine how? Equating second derivative to 0. We know even though the second derivative is 0, that is not sufficient for what exists in this points of inflection. We said no. At the points of inflection, second derivative is 0. That's true. But the converse is not true. What? Even though the second derivative is 0, nobody can say definitely there should exist what? Points of inflection. So therefore, we have to prove second derivative 0. We have to find x values. At that x values before and after, the sign of the second derivative, what people? Opposite. Then only we can say at those points, there are points of inflection. Right? Okay. Then you can write next part like this. Another table you have to prepare. Another table you have to prepare there. Right? You can write F double dash is given now, people. Double dash x given. F double dash x is (18 times x squared minus 33 divided by x minus 3 to the power 5. X not equal to 3, right? F double dash x, we have to equal to 0. At the point of inflection, we know that F double dash x should be 0. Conversely, not true. Then when we equate this is 0, people, the numerator must be 0, no? Numerator also this x squared minus 33 should be 0. X is plus or minus root 33. Okay. Then what are the intervals to find the second derivative? We have to put vertical asymptotes and x values at the second derivative becomes 0, no? Square root 33 means, people, a value between 5 and 6. A value between 5 and 6. Then at 3 we have vertical asymptote here plus root 33, here minus root 33. These are the intervals. The next one. Here f double dash x sign. Right, like put here like 10 minus 10, then here plus, but here minus. This is minus, no? We get plus here. Minus plus. You know what is this, people? Concave down, no? Concave down. Here, concave up. Right. So then there is what? At minus root 33, before that concave down, concave up on the right of that. There is what? Since the second derivative sign changes on either side of this minus root 33, there's a point of inflection here. Here, concave down. This is concave up. Right, people? Right, so now, for this table, 10 marks given. This table, 10 marks given. For the table, 10 marks. Now only we can say, people, where? At this minus square root 33 and plus square root 33, there are points of inflection. We are asked to find only the x coordinates of the points of inflection. So therefore, you must write that in words. Okay. And find in this x value plus or minus root 33, another 5 marks given. And now you have to write that in words. There are 2 inflection points. There are 2 inflection points. The last answer. Therefore, there are 2 points of inflection. x value plus root 33, x value minus root 33. For this, you are given another 5 marks finally. Understand? This way you have write the final answer. That's the first part. Right. Right, people. Next part. It says something like this. The adjoining figure shows a basin in the form of a frustum of right circular cone with a bottom. The slant height of the basin is 30 centimeters and the radius of the upper circular edge is twice the radius of the bottom. Let the radius of the bottom be r centimeters. Show that the volume v cubic centimeters of the basin is given by this. Right? Okay, who got this answer? Try to get this answer, people. People, this is the basin. I'll draw the cross section now. First, we'll draw like this. And this is 2r. This is r. This. But to find the people volume of this. What is the formula to find the volume of this? To find the volume of this, people, no, a formula. Right? We can complete, people, this cone, whole cone. This is obtained. This is obtained, people, like this. We have a complete cone. By that complete cone, we cut and remove this kind of cone. The upper part only taken here. That upper part is the basin. So then if we construct here this way, this is r, this is 2r, this is 30. Okay. Then you can very clearly see here, if you draw vertical dotted line here, like this, people. This is r. Therefore, this is also r. Then you can find this people height. Say capital H. How to find that capital H? Capital H squared plus simple r squared is 30 squared, no? Then H squared is 900 minus r squared. H is the root of this. Right. Even if you take here this angle as theta, okay, we need this height. We take this as simple h. What this height? Simple h. Then how to find this simple h? You can apply, people, this way. One relation. This is 90, no? Okay. Then you can write by this whole triangle. This is theta, this is also theta. Then by the whole triangle, you can write tan theta. What is that? 2r divided by simple h plus capital H. Tan theta, no? Opposite by the adjacent, no? H plus h. By this triangle, you can write. By this triangle, you can write tan theta r by h. These two tan theta values being equal, people. This and this you can cancel down. Then you can simplify this to find this simple h. Simple h is equal to capital H. This is capital H. Right. Yeah, we get that. Right. Finding this capital H figure, people, 5 marks given. Now we need to find the volume. How to find the volume, people, of this part? First, we find the volume of the whole thing. Volume of a cone is what? 1/3 pi r squared h. Of the bigger cone, its volume we find, and we subtract from that the lower part, the smaller cone volume. So thereby we get the volume of the basin, right? We are given the volume of the basin as V. For this V only, we need to take an answer. Now take V. What is the volume of a cone? 1/3 pi r squared h, no? This is the base radius, say r. This is the height h. And volume is 1/3 pi r squared h. Right. From the bigger one, we have subtract 1/3 pi. 2r is the radius. Now this height, people, it is h plus h. That means 2h, 2 capital H. Right. From that, we have to subtract the volume of the smaller cone. 1/3 pi r squared capital H. We get pi by 3 r squared. We can take out 2 squared is 4. Pi by 3 r squared we take out. 2 squared 4 into 2 is 8 h minus 8. Then here we get V. Pi by 3 r squared times 7h. Capital H is that. Substitute this, we get this answer. Write in this way the volume, 5 marks given. Now substitute this H, and then we get another 5 marks for the volume. Therefore, the volume V we can write 5/3, 7 5/3. 7 5/3 R squared H is this. This way. For this one, 5 marks given. Right. Now what is next? This is valid for R0 and 30. What's the reason? It should be positive, no? Volume V cannot be 0. This is valid for V greater than 0. For that people, this should be positive. 900 minus R squared, positive. That means what, people? 900 is R smaller than 30. R should be positive value because radius, length, no? Length may be negative. Right. So therefore, you get that answer also. What is that? R less than 30, greater than 0. Why? How do you know R greater than 0? R is positive because it's a length. Radius, no, this. That should be positive. That's why. Now we have to differentiate this. What is asking to find? Find the value of R such that the volume of the basin is maximum. R value we have determined for volume of the basin is maximum. Then we have differentiate this V with respect to R and take the answer of R. We can write dV by dr. This 7/3 constant. You have to apply here, people. U into V form. If this R squared as the same, I differentiate this. How differentiate the root sign? 1/2 times the same root multiplied by derivative of the part within the root. 900 is a constant minus R squared derivative is 2R plus keep this root part and multiply that by the derivative of R squared 2R. Right now? Then you can take here 2r we have. Here 2r we have. Take that out. And when we take a 2r out, here we get 2 and 7, 14. 5 times r divided by 3. Over there we have square root of 900 minus r squared. This is now minus 2r we have taken out now. Then minus sign r squared divided by 2 times 900 minus r squared. Then take the common denominator here. Common denominator is this. 2 times square root of 900 minus r squared. Then this thing should be multiplied by this. Then this root sign will eliminate. 2 times 900 minus r squared minus r squared. Now we can simplify this furthermore. dv by dr is equal to 14 pi r divided by 3. 2 into 900 is 1800 minus 3r squared divided by this. Here we can cancel down this. Here you can take 3 out, cancel down with this. Then dv by dr comes as people 7 pi r divided by square root of 900 minus r squared. Take 3 out from this and cancel down that 3 with this 3. Then here we get 600 minus r squared. Is a dv by dr. This is what we get. Then region up to here, people, apply u upon v form up to here 5 marks and simplifying all these things and coming to this 5 marks given. Right? There are 5 marks given. Now, not only this, for maximum or minimum v, dv by dr must be 0, no people, right? Yeah. Now come next. For maximum or minimum v, dv by dr equals 0. We get what? So 1 pi r, this. Should be 0. People, this r cannot be 0. This is obviously positive. Then for this left hand side to be 0, this must be 0. And there we get 600. We can write people how? 600 we can write 100 into 6, no? Its root. We get r equals 10 root 6. We don't take here plus or minus to right hand side. What is the reason? Reason is r is positive, no point of putting minus sign. Again, we have to ignore that minus sign. Then r is this. Now we need to find the sign of this dv by dr before this r value and after this r value to verify at this value of r is maximum. And now that part is the next part of this. Okay. Then there we get dv by dr r less than 10 root 6. Because 10 root 6, root 6 is nearly, it takes a value between 2 and 3 now. Root 4 is 2. Root 9 is 3. Then root 6 come in, people, between 2 and 3. Okay. Then 10 root 6 means, suppose this root 6 has 2.5. Then 10 and 2.5 is nearly 25 r. Okay. Then before 25 a value put for r, what can say, like 20. This is positive, no, all these people. This is positive. Then the sign of dv by dr is determined by the sign of this, right? Then substitute for that r like 20. Then when you put r 20 here, 20 squared is 400. 600 minus 400 is 200. That is positive. Therefore, dv by dr is positive. Okay. Next one. Put a value for this r which is greater than 2 root 6, 10 root 6. Okay. Then you can see dv by dr like put 25 here, 25 squared 625. 600 minus 625 means minus. Then you can see what v axis, the volume axis is here, r axis here, r value 10 root 6 is this. Before this, positive 0 and negative x. Then maximum. Therefore, at r equals 10 root 6, v is maximum. V is maximum. Okay, this is how we take that answer. Then people here, getting this r value 5 marks given. And finding the sign here, 5 marks for this 5 marks. V is maximum, r equals this 5 marks. This is how we take the marks. Okay. And that is how we take that answer. We have in the provided tutorial, take question number 19. This is a 2020 question. Right. Again, I give you few minutes. You are given fx x times 2x minus 3 divided by x minus 3 perfect squared for x not equal to 3. Sorry. (2020) question. We are given fx. X times 2x minus 3, x minus 3 power of x squared, x not equal to 3. So that f dash x, the derivative of fx given by this. All right, apply u upon v form and differentiate this. Square this, x minus 3 to the power 4, x minus 3 squared come in here. Here differentiate these people, right? When you differentiate this, you can do something like this. Multiply by this x, we get 2x squared. No? 2x squared, we get, when differentiate that, we get 4x. Minus, we get 3x. 3x root is 3. Minus x square, x times 2x minus 3. Derivative of this, 2 times x minus 3. One x minus 3 term you can cancel down like this. Then f dash x we get. We have to remove bracket here. 4x and x, 4x squared. Here also we get what? Minus 4x squared, no? 2 and 2, 4 minus x squared. Then x squared terms will cancel off. Now x terms. Here we get minus 12x minus 3x minus 15x. Then here we get plus 6x minus 9x coming, no? Minus 9x coming. And here we get plus 9 divided by x minus 3 to power 3. Then take this 9 out. Then we get 1 here minus 6. X minus 3 cube. This is true for x not equal to 3. If x equals 3, 3 minus 3, this is 0. 0 power 3 is 0. This is infinity. That has no meaning. Dash x. Right, now asking people this. Hence find the interval on which fx is increasing and the interval on which fx is decreasing. Also find coordinates of the turning points of fx. It is given that f double dash x. Second derivative given. Find the coordinates of the point of inflection of the graph of y equals fx. Sketch the graph of y equals fx indicating the asymptotes, turning points, and the point of inflection. People now asking here, increasing and decreasing intervals. People, increasing means this. When we have a graph, things like this. A graph is like this. Suppose this x coordinate is a, then this interval, the gradient is positive. In this case, when we walk along the x-axis to the right, then you can see as we move along the x-axis to right, this y is increasing. As x increases, that means when you move to the right, x increasing, no? As x increases, y increasing. Then we say, since this y is increasing, the graph is increasing. The graph is increasing. After x equals, say, when you furthermore move to right, then you can see this y decreasing. X increases, y decreases. Then we say from here to here, y decreasing. Therefore, remember, In this interval, gradient is negative. And therefore, simply the relation is, people, if the gradient is positive, this shape, no, as x increases, y increases. So therefore, graph is increasing. If the gradient is positive, graph is increasing. Gradient is negative, graph is decreasing. Okay. So therefore, by using the sign of the gradient dy by dx, you can determine whether the graph is increasing or decreasing. So therefore, that word increasing, decreasing, we identify like that. That means we have to find out the sign of dy by dx. That means gradient in each interval. If the gradient is positive, increasing, negative, decreasing. Right? Okay. Now asking turning points and point of inflection. Indicating asymptotes. All the things we have to find now. All things we have to find. We will now, so far for this differentiation, 25 marks come in. Application of u upon v, this one 20 marks given. For the final answer, 5 marks given like this. 5 marks given. Right? 25 marks coming. Right. Now people carry on the rest part. I think you can do the rest. Do the rest part. F dash x is okay. Right. Now start. Right now. After drawing that table, we can answer that increasing, decreasing part. Yeah, that's correct. That's the way, really. Right now, some student, of course, messaged me, sir, do we do the same lesson in the next 2 classes? Those people, of course, need to cover up the syllabus quickly, or sometimes they have missed the past lessons, past classes, and now they can't understand. People don't force me to cover the lessons quickly. I know how to do, when to do, what to do. Okay. So therefore, now you can actually, the people, they can work out this kind of question. They have a good satisfaction now and a glad feeling that you can very easily manage the questions. Right, people? So that is how we have to cover up a lesson. Otherwise, here and there, doing questions and wasting time and, right, cheating you, some classes, some masters, they do. That way I never do and I haven't done. So therefore, according to the way I tell you, you have to work. Otherwise, people, you can't come to good level, because I am, of course, not wasting time. I am always trying to give you the best thing, so that finally, end of the lesson, you can do at least the question in the past year sums. So now you can see some occasions in taking the answers of this, you find some difficulties, right? Even though people, the majority you can manage very easily. Okay, so therefore, that part, if you find difficult, people, that is because of your error. You haven't gone through that well. So therefore, don't try to cover up everything quickly, people. So that is not a good thing. Okay. Now, in 2021 batch, nowadays I am doing simple harmonic motion, right? So I finished center of gravity lesson. 18 questions I did big questions. 18 big questions. 18 means a good number. Most of the time, In some classes, at the most, they do 8 or 10 questions, at the most, not merely 10. So they do some questions only, but I did 18 questions. Now everybody, they can do questions. Most of the students, they say, now we can do that question 150 marks people in applied maths. Now simple harmonic motion also I am doing now. So far I have done 15 questions. Now they also, I try to use that exchanging the recording and giving that way, that process. Due to that, I think we can this time give 25 questions. 25 questions. So then another 10 questions I can very easily do. Like that we can do more sums. People doing more sums is the easiest way of getting rid of these issues in the maths. Otherwise, just having 5-6 questions is not enough. Okay. So therefore, don't be hurried to finish. We'll finish everything clearly and correctly, efficiently, not just to cover up the syllabus. Don't be hurry, people. Don't be hurry. Don't compare. I always say you don't compare my class with other classes. Other classes, sometimes they cover up lessons, 2-3 lessons per month. I don't mind people that. If somebody needs, they can go those classes, never mind. I do according to my style. This is not my style. This is the style we have to follow as a student. If you need to get a good pass, having a good idea. Okay. Otherwise, people, you can't answer whatever the type of question you get the examination, you can't catch that one. That means you can tackle that question. Okay. So therefore, don't be hurried. Right. So now, next one, you can write people, word lesson thoughts. For word lesson thoughts, the denominator must be 0, no people. X minus 3 power of x squared should be 0. X is 3. Horizontal asymptote. Take limit. Though you put y here, never mind. X plus or minus infinity. This way. People, you might say, sir, this question is very similar to the 19th question. No. See, yes, people. Yes. See here the rhythm. Only X letters different. The same little changes available. So that is how the question come in usually. That is why we must do more past paper sometime. After that, identifying the pattern of the past paper, you have to do some other questions. Okay. See the same pattern available. Same questions asked in 19 and 20. Okay. So then once you do the 21 question paper, then very similar question come in 22. Okay. So therefore, try to understand this pattern. So therefore, finally, end of the lesson, you should be able to work out, if possible, all the past paper sums up to 21 or 20 now. That's the thing, of course, to get the benefit at the examination. Do all the past paper sums. Some past paper sums you can't do, but leave them and others do. Right. Now, take x out from the numerator and x out from the denominator, and then put limit x infinity plus or minus. Also take x out here. 2 minus 3 upon x. Here also take x out. When it comes out from the perfect square, something like this we have. When put plus or minus infinity here and here, what do you get? Square here we have. And now this is 0. This is also 0. And here 2, this is 1, then this is 2. Then people, horizontal asymptote we get as 2. Right. For each 5 marks come in. Vertical asymptote 5 marks. Horizontal asymptote 5 marks. right? Now, next one is stationary points. Stationary points. Find the stationary points. For stationary points, dy by dx is 0, no? Okay, now, right? For stationary points, dy by dx 0, dy by dx means people f dash x. It's now 9 times 1 minus x divided by x minus 3 to the power 3. This should be 0 now. X equals 1. X equals 1. At x equals 1, we have to find y. Put x equals 1 in that fx. 1, 2 into 1 is 2 minus 3 is minus 1. Divided by 1 minus 3 is minus 2, then 4. Then we get 1 comma minus 1 by 4. Station point. This way we get. Right. Next one, we have to people construct the two tables, dy by dx table and second derivative table. Right. Then we'll first construct the first derivative table. Finding the stationary point, you get people x coordinate 5 marks, y coordinate 5 marks. Getting this 5 marks, substitute in that x value and get in the corresponding y value and write in this way the stationary point, another 5 marks coming. Another 5 marks coming. Right. First table is vertical asymptote x equals 3, stretch point 1, E3, E1. Right? Only 3 columns we have. Less than 1 and between 3. Let's see. F dash xo dy by dx, whichever, never mind, both are the same. X less than 1. This is f dash x. Like 0, put 0 here, numerator positive. This is negative, therefore this is negative. Decreasing now. And one entry, put 2. Here negative, here negative. This is positive. Increasing. Greater than 3, like 10, negative. Right. For these people, 5 marks given. This 5 marks, this 5 marks. Then this is written here. Fx is increasing in the interval this. Right. In this interval decreasing. This interval fx is increasing. This interval fx is decreasing. Right. Now, second derivative you have to take. You can now write point of inflection. For points of inflection, f double dash x is 0. F double dash x is given. What is that, people? This. It is 18 x upon x minus 3 power 4 equals 0. This gives x equals 0. If you put x equals 0 here and here and here, we can find fx, that means y coordinate. Y coordinate is 0. Therefore, point of inflection 0, 0. Point of inflection at 0, 0. Right. Then getting this one 5 marks and writing this way the point of inflection, other 5 marks coming. Right. Next one is the table, second derivative table. In this table, people, we put the values of vertical asymptotes, x values and x values at the point of inflection. Vertical asymptote we found to be at x equals 3, no? Here 0 and 3. X less than 0, 0 x3, this way. This is the f double dash x sign. Right. In this interval, x less than 0, f double dash x, we know. (18x) divided by x minus 3 to the power 4, no? In this interval, when x is negative, like -2, this is positive, no? This is negative. Between 0 and 3, put 1 there, positive. Greater than 3, also positive. Second derivative negative mean what, people? Concave down here. This is available in the note. In the previous question also, one student asked, so how to determine this? Go to that note. Completely I give this note. This is concave down. Then the graph lies below the tangent. Concave up. Also concave up. Then the concavity changes at 0. On the left, concave down. On the right of 0, concave up. Then that point only, people, the point of inflection, because we define the point of inflection to be how? The point at which the concavity of the graph changes. Concave down to concave up, or concave up to concave down. That point only we define as the point of inflection, right? Now at 0, 0, people, we have therefore point of inflection. Point of inflection is, people, 0, 0. So then here, for this, really 5 marks given for this. For this 5 marks. For this 5 marks. Only 10 marks given to that. Then at 0, 0 point. Why 0, 0 we say? At x equals 0, we found y0. People, after deciding the signs minus and plus on either side of this 0 second derivative, you know, at the point of inflection, if we know already there is a point of inflection, we know second derivative is definitely 0. We suppose we have a point of inflection at the moment, then the second derivative at that point definitely 0. But though already the second derivative is 0, that doesn't say, people, definitely there should be a point of inflection. You know, the converse is not true. So therefore, people, in this case, we got this x equals 0 by equating this second derivative to 0. Then we got x equals 0, and we found y also. Then x equals 0, y equals 0 we got by equating second derivative 0. But 0, 0 point, even though we have that x0 by obtaining that second derivative equal to 0, it doesn't say, people, definitely at 0, 0 there is a point of inflection. After that, by this table, on either side of this 0, because of the sign of second derivative is changing opposite. By that only, now we can definitely say, therefore, at 0, 0 point on the left and right, the concavity changes. Therefore, what can you say? There's a point of inflection. Right? So then you can write after this, therefore, at 0, 0, there exists a point of inflection. Right? At 0, 0, therefore, at 0, 0, 0, 0 is point of inflection. Point of inflection. Right. For that, you get another 5 marks. For this, you get another 5 marks. Now, people, you have to what? Draw the graph. Right. Now sketch graph, people. Sketch graph. Right now, I equated f double dash x to 0 to find the point of inflection. Then we get x equals 0. That x equals 0 I substituted via here. Then we get y equals 0. Then 0, 0, there can be a point of inflection. Right? We don't know that yet. We can't confirm that yet. Then that is confirmed by using the table. Now, second derivative table we prepared here. You know, in preparing this, we have to put there x values, the second derivative becomes 0, and x values, vertical asymptotes available. Then 0 and 3, no. And now prepare the table like this: less than 0, between 0 and 3, greater than 3. Right. Then second derivative signs are this: concave down, concave up, concave up. Then at 0, x equals 0, concavity changes from down to up. That means concavity changes at x equals 0. Then there is a point of inflection. Then the graph passing through 0, 0. And we sketched the OXY plane, and now we are going to sketch the graph. At x equals 3, we have vertical asymptote, and station point is at 1 minus 1 by 4. Minus 1 by 4 is should be closer than this, no? This is the O. Zero to 3, concave up people. Less than 0, concave down. Then like this. Concave up means graph should be above the tangents, no? On the left of 0, concave down. That means graph should be below the tangents. Then here you have to very clearly draw that. This way. See here, when we construct the tangent at the 0, 0 point to the graph, that tangent is passed in crossing the graph like this. Look at this. Here, when you try to draw the tangent, that tangent crosses the graph. So therefore, this is the point of inflection. Here it is mentioned there. This is the point of inflection by putting an arrow in the marking. Point of inflection. 5 marks given for this. Then the other part is like this. This way. And on the right hand side of 3, gradient is negative. At y equals 2, there is a horizontal asymptote. So therefore the graph should be like this. No? This is the graph now. People, in this case, marks come in like this. For this portion, draw in correctly, 5 marks. And show in this minimum point, 5 marks. Remember, at the stationary point, people very clearly, you have to show the coordinates. Either write in here or pointing out like this. Right? That way. And mention in this vertical asymptote, 5 marks given. Mention in this horizontal asymptote, 5 marks given. Draw in correctly the graph. Here, 5 marks given. See here, this portion 5 marks, this portion 5 marks, this portion 5 marks, vertical asymptote, this stationary point, point of inflection, marks given. So then this is the marks coming. This is how we do the first part. Right now, people, this sort of workload available to do at the examination. So therefore, you have to expect this kind of questions. See here, more works available there. So therefore, at least the same questions you have to do as homework. 2-3 times do people to increase your working skill. So therefore, most of the time you can work out the question by taking more time. But remember, people, at the examination, you must do all the requirement, all the questions you have to do within 3 hours. That's also another difficult task. So that also you have to train during this practice, because anybody can answer people any paper if they will be given unlimited time, but within 3 hours we have to do everything. That is the next one you have to practice during a particular time interval. Usually 25 marks for the whole question we can take, but at the moment, according to your way, within 25 minutes you can't do this one. Right. That's how we do that part. Even next one given. Next part given. So very easy part is the next part. Read next part. Application, second application. At part B. At the adjoint figure shows the portion of a dustpan without its handle. Its dimensions in centimeter. As shown in the figure, it is given that the volume x squared h cubic centimeters is 4,500 cubic centimeters. Its surface area is square centimeters given by this. Show that S is minimum when x equals 15. Very simple sum, people. Very simple sum, right? So the surface area and the volume both are given. Only thing the student should subject from one the other and differentiating. Right, take that. This is dustpan. This is given as x. It's 2x. This is h. The volume x squared h is 4,500. Then people will subject h by this. Number one. Secondly, the surface area given is 2x squared 3xh. So for this h, we will substitute by this 4,500 divided by x squared. 1x we can cancel down. 2x squared uh, 3 into 4,500, no? 13,500 divided by x is s. S is minimum when x equals 15. So we have to differentiate this now. Getting this one, 5 marks coming, people. Differentiate this, another 5 marks come in, equate that to 0, 5 marks come in, find in next 5 marks. Showing the sign of ds by dx 5 and getting the final answer another 5, altogether 35 marks for this. That is more easy part. ds by dx 4x here. Right, here how differentiate? Bring this x to numerator. X to the power minus 1 coming. How differentiate that? Bring minus 1 before and x to the power minus 1, minus 1, minus 2. Then what do we get? Minus 30,500 divided by x squared, no? For maximum or minimum, ds by dx equals 0. This way we get. Multiplied by x cube, x squared. And here we get 4x cube equals 13,500. Cancel down by 4. Here 3. 15 people we get. Again 3, no? Then 30. 7, 5. Then cube root of this 15. Am I correct? This is 5 marks. For the differentiation, 5 marks. For the maximum minimum, this is 5 marks. Getting this one, 5 marks. Right, people, for ds by dx equating to 0, 10 marks given, not 5 marks. 10 marks given this one. The concept 10 marks given, right? Then 5, 25, 35 coming, right? Then find the sign of ds by dx. ds by dx sign this x less than 15. Like put 10. We have to prove this is minimum, no? It is real people negative. When you put here 10, x is 10, this is 40, but this is more than 40, no? Negative. This way. Then you can say surface area here, x-axis this is 15, negative, 0, positive, minimum. So therefore, finding this science paper, 5 marks given for both. Write in final answer in terms s is minimum when x equals 15, another 5 marks given. Okay. So therefore, last one you have right. Therefore, S is minimum when x equals 15 centimeters. The units is not anyway people important. In the marking also, the units is not put 5 marks for this. Right. So this is how we take that answer. Right, now take people, you want a break? Without a break, shall we continue another half an hour? Okay, no? Asking, so we can use a second derivative test to determine maximum minimum possible, because second derivative we use for the point of inflection possible. If somebody wants this recording, please send your Gmail, right? Gmail or email address. And I am registering here you in Zoom. Soon after, of course, registering, you will receive an email. Activate your Zoom account. You have to activate that and send me back. Then, secondly, you will receive another email, all right, with a link. In that email, when you click that, you have to fill different places. Short answers asking them. Complete that and again send. Then I receive that. Then I can approve your ability of watching the recording. Right. So then those who need the recording, you have to give your what the email address. And whenever you need to watch the recording, people, you have to access through your email account to watch the recording. Now, some students, they give their email, but once they watch the recording, they go through another email. Then they say, we can't watch this one. Okay. And don't give your Gmail to any other one, right? Because if somebody watching at the moment with your Gmail, then meantime you can't watch. Okay, so that is how hereinafter I'm supposed to give. Then I can know really this student watched the recording or not. In your name and everything you have to fill in that, right? Otherwise, I am not approving you. Some people, they put that and there's some other names. I remove them really. Your parents given a good name to you, know. If somebody use the other gum namdani එහෙම ඉන්න එපා මම ඔක්කොම approve කරන්නේ නැහැ. ඕගොල්ලෝ මට දෙලා නමෙන් එන්න. අම්මා තාත්තා නම දීලා තියෙන එකෙන් එන්නනේ. එකෙන් එන්න. ඊට පස්සේ මම දන්නවා කවුද රෙකෝඩින් එක watch කරන්නේ නැත්ද කවුද කියලා. ඉතින් watch කරන්නේ නැති කෙනෙක් පන්ති වලට නැහැ. ආයෙ රෙකෝඩින් වල වැඩකුත් නැහැ. So recording එකෙන් බලන්න. Right, huh? Right. Then first step is what? You have to send me your Gmail or the email address. So then I put that in my Zoom. Then you will receive what email. Activate that. Okay. Secondly, another link is coming. There you have to fill something, your name, your Gmail, and your password, everything. And then submit that. Then I get that one. Then only I can give you the approve to watch the recording. Okay. 2 times you have to expect the emails from me, right? From me, right? Yeah. Right. Next part. Question number 20, part C in the tutorial, new tutorial. A cascade shown in the figure is to be formed within tin. You know the meaning of tin, huh? Very thin, what metal sheet. The cascade consists of hollow hemisphere of radius simple r and hollow cylinder of radius 2r. The hemispherical part is joined to the upper flat surface of the cylinder by removing common area for both from the upper flat surface of the cylinder. If the area of the cascade is capital A, show that 3r less than root a by pi. Also find the values of r and h which maximize the volume of the cascade. Right? This way we have. This is 2r. This is H. This is R. Right. Right. So then what is the surface area? If the area of the cascade is A. Right. People, how to write area? This bottom, what is that? Pi radius squared. This curved part. Shall I take then this also? Bottom is this, top is this. Right. Then same area now I multiply by 2. But there's a hole that I have to subtract pi r squared. No. Now this bottom pi times 2r squared, top also pi times 2r squared. That is why I multiply by 2, pi times 2r squared. But there's a hole here, no, that I have subtracted. Another surface area available of this hemisphere. What is the surface area of a sphere? If the radius is r, 4 pi r squared, no? Surface area of a sphere, 4 pi r squared. Then here we have half of that, 2 pi r squared, right? I have to add, that is the area of this. Another one we have this way, right? What is that? People, now this curved part of the cylinder, if you take this curved part, people, when we cut this way and stretch this, it's going to be what? This way, but a certain, what people? Rectangle. It's this length going to be the circumference of this. 2 pi radius 2r, height is h. Then the product we get 4 pi rh. Right, people? This is what we get. I will simplify this. What do you get? A equals here 2 squared 4.28 pi r squared. Pi r squared, 2 pi r squared means, people, pi r squared. 4 pi r h. Then here A equals 9 pi r squared 4 pi r h. Then we can subject h by these, people. What is h? A minus 9 pi r squared divided by 4 pi r. So we get this h. Well, you know, this cascade has particular height, no? Then h should be positive. But it should be positive. The denominator is obviously positive. R is length, no, positive. Therefore, for this fraction to be positive, the numerator should be positive. A minus 9 pi r squared positive. Then, what is the answer asking? 3r, no? A greater than 9 pi r squared. Take this A to denominator, left hand side. 3r perfect squared. Then take root of this. Right, I wrote this 9r squared as 3r perfect squared and put the positive square root. Right, this gives us 3r less than square root of a upon 5. A upon 5. First answer you obtained. Also find the values of R and H which maximize the volume of the casket. Volume of the casket. H equals yes. The volume can be found, people. What is the volume? Volume of the casket is what, people? Volume of this cylinder plus what? This portion. Volume of cylinder. What is the volume of cylinder? Base area pi 2r squared into height plus here we have hemisphere. No? Area of a sphere, what, people? 4 by 3 pi r cube. Half of that here we have. Sum of that two is the total volume. Right. Now we'll write volume. Volume. We'll take V. What is that? Base area pi 2r squared. H. This. Base area pi r squared, no 2r there. H. Plus what? Here. Volume is, people, 4 by 3 pi r cube of the whole sphere, but there we have half, no? Then we have divided by this 2. Then we get 2 coming in. Now here for this h we can substitute by this. Here we get 2 squared is 4 pi r squared. For this h I substitute by this. Okay, minus 9 pi r squared divided by 4 pi r. 2/3 pi r cube. Here 4 pi and r. 4 pi and r. Can write. Here we get 8 times r minus 9 pi r cube. Two-thirds pi r cube. What do you get? 27 minus and then minus 25 pi r cube by 3. This is the volume V in terms of R. Then we get dV by dr. Here A. Here, what do you get? 5 times 3r squared. You can cancel down this. So maximum or minimum volume, people, this dV by dr must be 0. For maximum or minimum volume, dV by dr should be equal to 0. I write dV by dr, people, again here. equal this to 0. A minus 25 pi r squared equals 0. Subject r squared by this. A divided by 25 times pi. R means 1 over 5 A over pi root. This is the R value. Now we have to find the sign dv upon dr. Actually, we can use here second derivative also. Shall we use the second derivative? Much easier, no? Right. d2v upon dr2. People, this a is a constant, no? A is a constant. Area a constant, no? 0. Here 55 times r. R is that figure. This is positive quantity. Minus 55, this r 1 upon 5. This, people, you can see because of this minus sign, the whole thing is negative. Second derivative negative at r equals this answer. Second derivative negative means what, people? Second derivative negative means, we said second derivative negative means it is corresponding to what? Maximum, no? Second derivative negative means maximum. Second derivative positive means minimum. So therefore, volume is maximum when r equals this answer. And therefore, you can write volume is maximum. Volume is maximum at this value of r. V is maximum when r equals this answer. Right. Not only that, h also we need to find there. Both r and h we are asked to find now. H is this. H can then be found, people. A minus 9 pi r square. R square is square of that. 1 upon 25 a upon 5 divided by 4 pi r means this. B upon 5. Simplify this, you get the answer for h. Right now?